Right. So as we mentioned earlier, there are three types of uh, mapping that we're going to consider. Right. The first one being texture mapping, where basically we take our triangles, our faces that implement our surfaces in our geometry, and then we just fill in all the pixels on those polygons. Right. If we have just three vertices, we do we have to know what is that we're going to do with each one of the pixels inside of the polygon. And up to this point, we've been just using just a flat color, right? Either green, red, whatnot. And if we're just looking at a single normal, then the entire surface, that entire triangle, gets the same color. So every pixel inside of that, those three vertices get the same color. So we're obviously, if you're considering Phong or Gerard, we can interpolate and make it smoother, so that each pixel instead gets a different color depending on the various normals that we might interpolate. But we want to go back to this and say, well, what if we use texture mapping, where we have images and then fill in those polygons from pixel information, color information that we get from an image. Or environment mapping or reflection mapping is where we might have an image that represents an environment, maybe some kind of room, or outside in the woods, or on campus, that we have a spherical representation of that environment. Either we took it with our phone and we used our panning feature that we just went around 360 degrees, and then we stitched it together. And then if we use that texture of that environment and then map that on top of a sphere or a car or some geometry, and then we're trying to represent the fact as if that object would be highly specular, where very very shiny. It looks as if it's reflecting, right, the environment, right, that is around it, and that allows us to implement or simulate highly specular surfaces that look as if they're reflecting their environment. So there's also bump mapping, right? That we iterate over the images or the surface, we can add different variations of the normal that gives us the simulation of ridges and valleys, and as having much more information than we actually have.